Alright, welcome to our last video of Chapter 3. So when we were talking about the law of definite proportions, we're going to talk about the law of definite proportions, the law of multiple proportions, and calculating percent by mass. So you definitely need a calculator for this one. So the law of definite proportions states that a compound is always composed of the same elements in the same proportion by mass, no matter how large or small the sample. Well, that makes sense. Definite proportions. It's going to be in the same proportion. So that means if I have 5 grams of water, 100 grams of water, and 100,000 grams of water, no matter how much water I have, the amount of hydrogen to oxygen is going to be in a definite proportion to each other. That doesn't mean that they're going to be the same amount, but they're going to be in a definite proportion by mass. So when we're talking about the law of definite proportion, that means no matter what compound I have, because it's a pure substance, it is going to be that same proportion. To prove this, we use what's called percent by mass. And percent by mass is a ratio. And it is going to be the ratio of the element to the total mass of the compound expressed as a percentage. So when I look at that, the formula is going to be the mass of the element divided by the mass of the compound times 100. Now remember, all of my percent by masses for a specific compound should add up to equal 100 because it's a percentage. So if I look at sucrose, and sucrose is sugar. If I have 220 grams of sugar versus 500 grams of sugar, no matter how much, no matter the mass, I should always have 42.2% carbon, 6.5% hydrogen, and 51.3% oxygen. When I add that up, they should equal 100. But if you look, analysis by mass, their mass amounts are different, but the percentage, the proportion is the same. So right here, it says that I have 168.02 grams of baking soda. It has 45.98 grams of sodium. What is the percent by mass of sodium in the sample? So baking soda, its formula, and we'll talk about this more in Chapter 7, it's called sodium bicarbonate. So its formula is HCO3. So that's Na is sodium, H is hydrogen, C is carbon, and O3 is 3 oxygen atoms. So right here it asks, what is the percent by mass of sodium in the sample? So I'm going to start, and I'm going to say percent by mass, and its formula is the element, remember, divided by the total compound mass, and then I multiply that times 100. So I'm going to take this 45.98 grams of sodium and divide that by 168.02 grams of baking soda. And then I'm going to multiply that by 100. And I don't know why that just zoomed in. So then I'm going to multiply that times 100. So when I take my calculator and I do 45.98 divided by 168.02, I hit enter, I get 0.27365787979. Then I multiply that times 100, and the percent by mass of sodium in that compound is 27.37%. Alright, stop zooming in, computer. So, 27.37%. Our mathematical answers, try to go out to 2 decimal places and make sure you include your units. So right here it says I've got 3 grams of hydrogen. It reacts with 14 grams of nitrogen to make ammonia. What is the percent by mass of hydrogen in the sample? Well, remember, percent by mass is still going to be the element, and that's not how you spell element, divided by compound, times 100. So right here, it's percent by mass of hydrogen. So that means the mass of hydrogen, which is 3, needs to go in the numerator. And the mistake a lot of people make is they're like, oh, there's 14 grams of nitrogen. Okay, that's my compound. But nitrogen's on the periodic table. It's an element. So what I'm going to have to do is go back and think back to the law of conservation of mass. And remember how we said that the mass of the reactants equals the mass of the products. So I'm going to think, okay, I've got hydrogen, I've got nitrogen, and those react with each other to make ammonia. So my hydrogen is 3 grams, my nitrogen is 14 grams. I got to figure out how many grams of ammonia I have. Well, 3 plus 14 is 17 grams. So that's my compound. So 17 grams goes in up here for the mass of the compound. Now I can figure out my percent by mass. I can do 3 divided by 17. When I plug that into my calculator, I get 0.17647. And then I multiply that times 100, because it's a percentage. And my percent by mass of hydrogen in ammonia is 17.65. So that is my percent by mass of hydrogen in the sample. So we have the law of definite proportions, which we just talked about. We also have the law of multiple proportions. And this one isn't as important to us in general chemistry, but when you go to college, if you take further chemistry classes, the law of multiple proportions will be more important. And basically what it states is that if you have different compounds, so we're not talking about water and water, now we're talking about water versus sugar, or water versus hydrogen peroxide, and they are formed by a combination of the same elements. Still remember, different compounds, same makeup. They're going to combine with each other in the same relative mass of the other element and the whole number ratios. Basically what that means is that no matter what I have, carbon is going to want to bond with hydrogen, no matter what compound it is, what chemical it is, in the same relative mass. It's not going to change that much. So when I have hydrogen peroxide, which is H2O2, and I have water, if you drink hydrogen peroxide, you're dead. If you drink water, you're alive. They're going to combine in the same relative mass to each other. And then you've got copper 1 chloride and copper 2 chloride. Copper 1 chloride's formula looks like this, and copper 2 chloride's looks like this. So they're generally the same relative mass to each other. So if you look at this, the percentages are not going to be that far off of each other. So that's the law of multiple proportions. And now we're going to talk very briefly about going back to mixtures and compounds and elements. So we talk about mixtures versus substances. Remember, mixtures are separated due to physical means. So that means I can physically take it apart. It's not going to have to undergo a chemical change. So when I am looking at separating something based on physical means, there are 5 different ways I could separate something. One of them is using filtration. So that's a technique using a porous barrier to separate a solid from a liquid. So if I am filtering coffee, so if your parents make coffee at home in the mornings, they take coffee grounds probably, and they use coffee filters to keep the grounds from getting into the liquid. Our next one is called distillation. Distillation is a separation technique that separates homogeneous mixtures based on the differences in boiling points. If you've ever heard of the Jack Daniel's distillery in Lynchburg or any sort of distillery, The reason that they're called distilleries is because what they do is they distill the alcohol out of the water, because alcohol has a different boiling point than water does. So you heat it up, and at about 89 degrees, alcohol is going to boil out of the water, so you're able to separate it and make purer alcohol and purer water. This is something that if you've ever seen a High School Musical, or if you saw Spider-Man Homecoming, distillation kits are what Hollywood loves to set up in chemistry classrooms, because they are large and glass and complicated looking, but they're really not that bad. Crystallization is another way that you can separate mixtures. I can take a homogeneous mixture and I can force the pure solid particles to form a crystal. So if you've ever made rock candy, this is crystallization of the sugar. Sublimation is the process of a solid changing directly to a gas. So if I have a solid that sublimates like dry ice, and there's something else stuck in the dry ice, it will sublimate and dissipate, go straight from being a solid to a gas, and not become a liquid in the middle, and leave the other compound or element that was in the mixture. And last but not least, chromatography. So what chromatography is, and you've probably heard of chromatography if you've ever watched NCIS or CSI or any sort of cop show that has a science lab in it. It is a technique to separate components of a mixture based on the tendency of each to travel across the surface of another material. So if I spray chromatography solution on a shirt, and I don't know what liquid is on the shirt, so if I'm working a CSU unit with Metro Nashville Police Department, and I spray the chromatography on a shirt, and then transfer the unknown liquid that's on the shirt onto a piece of chromatography paper. The distance it travels, if it travels a certain number of millimeters, I know it's blood. If it's a different number of millimeters, I know it is urine. If it's a different number of millimeters, I know it's saliva. If it's a different number of millimeters, I know it's some sort of other bodily fluid. So those are all ways to separate components of a mixture based on the tendency to travel, or based on whether they sublimate, based on whether they filter, based on whether they distill, or based on whether they crystallize. So, thanks for your attention, and we are done with Chapter 3.